G'day once again, everyone, and we are still working with 5.2 mathematics trigonometry in New South Wales. This will be the last video in this particular series, and we are going to find unknown angles this time. So up until now we have found what the ratios actually are and labelled sides. We have then found unknown sides where it was in the numerator, and we have unknown sides where it is in the denominator. Now in this one we're actually looking at unknown angles. Now you can see here there's a little bit of a tricky bit because we have our cos ratio, but there's a little -1 there. That little -1 indicates the inverse of our ratio. It's kind of like the opposite or the upside down version, okay? It's not really what it means, but it's kind of that idea, right? So we're using it the backwards way or the upside down way. We can do this on our calculator if we use the shift key, right? So that's the shift key. Or second, okay, so shift and or second function, it could be called second function, and then on this particular calculator, if I do that circle a little bit better, we have our sine, cosine and tangent buttons. So we have shift or second function, depending on which one you have on your calculator. Then either the sine key, the cosine key, or the tan key, and that will get us to our inverse ratios. Okay, so that's what we're going to be doing. So let's have a look. We've got a couple of questions to get through just to show you what's happening here. Okay, so our first one is find the value of theta to the nearest degree if sine theta equals 0.3907. Okay. So what we're going to do, so we have sine of theta equals 0.3907. We want the inverse to get theta because we want theta to be the subject, so we want theta on its own, and it'll be sine to the -1. Remember that little -1 indicates that we're using the inverse. Then we pop our number in, okay, and then we type that bit on the right hand side into our calculator. So let's see how it works. So I go second, mine says second function, yours might say shift, okay, second, and I need my sine, and my keys are in a little bit of a different spot to my diagram before. Then I type in my number 0.3907, close off my bracket, and hit equals. Is 22.99806, 22.99806, but I want this one to be to the nearest degree. So nearest degree means nearest whole number. So nearest whole number. Okay, so I'm going to cut off at that decimal point because I want a whole number. look at the next number along. It is above halfway. So I end up with 23 degrees. Okay, our next one along. Alright, we want theta to 2 decimal places this time. If tan theta is 1 over 2. So let's write it in. Tan theta equals 1 over 2. I want theta on its own, so I go theta tan to the minus 1, indicating the inverse. 1 over 2. Okay, and then we use our calculator once again. Alright, so again, second tan, so we get that minus 1 up there. Close off our brackets, and we get 26.5650. Okay, I want 2 decimal places for this one. Cut it off at the second decimal place. Look at that third one. We are above halfway. So that means that 6, this 6 here, needs to become a 7. Okay, so it's 26.57 degrees. Our next one along is once again to the nearest degree. Nearest degree meaning nearest whole number. Okay, if we label our sides, hypotenuse, opposite, adjacent, we're going to be using sine again. So sine theta equals opposite over hypotenuse. We've got sine of theta is 6 over 10. Doing exactly the same as what we did before. Theta is sine to the minus 1, so we've got our inverse. 6 over 10. Okay, so second function, sine 6 over 10. Close off the bracket, hit equals, and we've got 36.869, etc. And we want nearest degree, so we cut it off at that decimal point because that's the end of the whole number. We're definitely above halfway here. So that 36 becomes 37. That's how easy it is. Don't forget to put your degree sign. Good luck with your questions on these, and see you in the next series.